So
Okay.
was everyone able to do the preparation assignment? Do they have any questions?
Yeah, I did both the preparation assignment and the homework, but I didn't do either one of the quizzes yet, of course. So.
Okay. How about you, Phil? Any questions about?
I pretty much everything. This one I had no idea what was going on in this one. I'm so confused.
So something that helped me. Do you have screenshot on your computer, Phil? Do you know what that
I'm
is?
not sure.
Or like a snippet?
No idea.
So if you can after this class, Google like snippet, and it's a free download.
Oh, I have that. It's right there.
Okay, it has like
Yeah.
So
Yeah, scissors. Yeah.
something that helped just keep everything straight for me this lesson was on the not the tutorials, on the helps. Hold on. Oh, hold on.
Like the lesson 6 part 1 doesn't.
So under, when you go under the individual prep, and it has like the following links complement the reading, and there are 2 of them. There was a part.
Mm-hmm.
Go to those, and then the guy who's leading the discussion or whatever, the lesson, he has a bunch of the headers of them are always like block blue. Then he gives you all of the formulas and a couple of the examples, and so I just snipped them, and then I put them on my own little word processing sheet, and it helped a lot because then I can just quick reference, and then I was able to follow him a lot easier because he goes through it so fast.
He goes through it really fast. Yeah.
Like, wait, what? But if you snip those, and there's like 8 of them. No, there's 7 of them. Anyway, that helps a lot. And then when I went to the video tutorials at the very bottom of the preparation, I was like, how did I not get this the first time?
Mm-hmm.
It's a lot. It made so much sense.
And it might have been I was doing homework for like 4 hours last night, and I ended at 1, and so I started reading this at like 1 in the morning. So I was like,
yeah.
So I'm sure that had a lot to do with it as well.
Yeah. Yes.
Okay.
Yeah, I know what you're saying.
I will do that.
And for me at least too, I'm very visual learner. So if I can see it and then rewrite it, I'm usually pretty good. I can.
Okay. That's how I am too.
Help to have that tool. So do you guys just want to? Do you want to go through the homework, or do you want to just start on the quiz? Would it help to go through the homework?
Yeah.
Okay.
I don't want to waste you guys' time, so let's just do the quiz, and then I can do.
It's not a waste. It'll just help cement it more for us, I think.
Okay.
I'm good either way. I think I generally got it. I just yeah.
Let's go through the homework, or not the homework, the
preparation assignment.
Yeah. It's pretty fast, and it'll, I don't know how to screen share.
It's like a little green tablet. There's like a green screen to the left. Like if you put your arrow towards the left of the screen, there's like a little computer icon with an arrow on it, and it says screen share. I don't know if you guys can share or if it's only me, since I'm doing the broadcasting.
Yeah, I don't
You're in control.
Okay. You want me
Oh
to?
yeah, no, I see it.
Oh,
Okay.
yeah. Okay.
So let me see if I can figure out how to share. So do I have to be in a different? So how do I get a page that was open? You know, on like.
So when you click on it, it should kind of show you what's on your desktop, and then you just
Okay, so I
select
have to click on
select the document that you want to share, and just click on it, and then it should say start sharing.
that. Okay.
I mean, I think I have the answer key.
Yeah, if you want to pull that up.
Sure. Preparation assignment. I think this is it.
Okay, I've got mine.
Oh,
Can you see that?
I went out of
Yeah.
it, so I'll stop sharing. So hold
Oh,
on.
I've done that before.
Oh yeah,
Okay.
I see yours. Okay.
Okay, so question 1, what is the sampling distribution? So do you understand what that's asking? Does everyone understand what that's asking?
Mm-hmm. I think so.
Yeah.
At first I was thinking that oh wait, no, that's for the next question. So that one's pretty obvious.
Yeah, I think it was like the set of all possible values x that could occur. Is that right?
Yeah.
Okay.
So did you guys get a chance to go on that other link that they had during the actual reading, the lesson reading, where you would practice putting in different numbers?
Yeah.
So just all
Yeah.
all of the possible.
Mm-hmm.
Okay, 2, what is the shape of sampling distribution of the sample mean when the data are normally distributed?
It's normal or bell-shaped, yeah.
So
But I think
so it would be the same thing, because I was thinking bell-shaped.
yeah.
Then when you said normal, but do you think those are interchangeable?
Yeah.
Okay, so that makes sense then.
Normal is bell-shaped, so it's just
Okay.
yeah.
Okay. Does that make sense, Phil? Do you got that?
Yeah.
Because like
Yeah,
the
it
ones
does.
that are left and right skewed, those would not be normal.
Yeah.
Okay, so what's the shape of the sampling distribution of the sample means when the data are not normally distributed, but the sample size is large? And that goes back to either it would be the central limit term, right?
Yes.
Or the large number, I'm not sure which one, but anyway, it'd be approximately normal.
Right. It's approximately normal, yeah, or bell-shaped. I think that's the central. Okay, so we need to know the difference between the central limit theorem and the law of large numbers.
Right.
And basically, I think that I think it's the law of large numbers. So the size increases and the sample mean draws closer to the population mean as the what's it called?
Numbers go up.
Yeah, well that goes up, but then the what's the
So one of the things that I think it was from the tutorial, one of the things that he said was that kind of clicked in my mind was the central limit theorem has to do with the distribution of the shape, whereas the large law of large
Yes.
numbers has to do with it just going closer to the middle, the more accurate mean.
Right, and the what is it called? What's the
Oh,
other
okay.
thing with the mean, and then we find the
Oh, deviation? No.
deviation. Thank you. Yeah, the deviation will actually go down on the law. I think it's the law of large numbers, I believe.
Yeah, you're right.
Okay.
Yeah, the large numbers, it will
Mhm.
get closer to the middle, so that means the deviation is smaller. But that makes sense.
And that is on the homework
Okay.
assignment. That is a question, it's like a multiple choice in the homework assignment, and that's the right answer. Is that one has to do with the shape, while the other one has to do with the spread.
Yeah,
Yeah.
that makes sense.
Hmm.
I like
So.
that.
Okay.
Okay. I kind of missed 4, but does everybody get that one? It's basically the same thing. It was just talking about the distribution of the sample. When
Yeah.
it's increased, then it's, if everything's,
It becomes normal. Yeah.
yeah.
Normal distributed, standard deviation decreases, mean is unchanged.
That's basically the law of large numbers, isn't it?
I think so.
So when is the X bar normally distributed? And I had a question about that one. I understand how they got the answer, but what is the X bar?
A good question. I don't know if I knew.
I don't.
I
I
think
don't know.
X is like the population. Is that right? Population bar normally distributed. Is that what they're asking?
Oh, maybe you're right. I just wasn't sure what the definition of X bar was.
Yeah, I wasn't really sure either, but I think that's what it is. This is just the population that they're.
I wonder if that is the parent population.
Mm-hmm.
Oh,
So this is when it's normal or when some sample size is sufficiently large.
okay, yeah, that makes sense. Okay. So part 2 was that multiple.
Yeah.
Did you guys have a chance to do that? It's pretty simple.
Yeah.
It's just you basically pick 5 random,
Right.
of those 5 values, and then you find the mean.
It asked though what's unusual, and I didn't really know. I was like, I don't know. It's off to the right.
So he was saying that in that variation guide thing too, or in the tutorial, he was saying that unless it's really on the fringes of the, on the outsides of the bell curve, it will be normal.
Oh, okay.
And if you're in sort of that 4,300 area, or the 500,000 area, or the $50,000 area, it's
all normal. Okay.
Yeah.
Okay.
I don't know why, because I would
Weird,
think
but-
that's kind of far, but that might be something we want to ask
Yeah.
Professor or Brother.
Brother Bennett, yeah. No, that was the only question I didn't really understand, because I was like, I don't know. I guess it's in the bell curve, but I don't know if it's normal or not. Or unusual or not is what the question was. And then after I added some more, it drew closer to the mean, which is the I don't know.
Law of large numbers.
Yeah. Law of large number. I just want to keep saying the central limit theorem, but that's. I still am kind of confused between those two, but I understand that they're different, but yeah.
I know. I just have to keep. One's the shape, and one's the spread.
Right.
That does help. But okay. What did you notice in practice? The same. Well, we just talked about that. Okay, so the graduate management, we're on question 8.
Mm-hmm.
Admission test, or the GMAT, is used as an admission criterion in many Masters of Business Administration programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample of N or 10 students taking the GMAT. What is the shape of the distribution of the sample means for all such samples? I had a question about this one because the answer is normally distributed, but how can you figure that with the... He was saying that it's because the parent population, which is the second question, is normally distributed and it's a large number. But how can you tell if it's a large number if this from the mean, the deviation, and the number of students? Because I was thinking that the number of students is only 10, and from what I remember, somewhere along the line, maybe it was the
Yes. Yeah.
They were saying about 30 and up, it would be considered a large sample.
Yeah, I took notes on that. Okay, so if the parent population is normal, it equals a normal distribution. If the parent population is not normal, it's approximate normally distribution. If the parent population is almost normal, the sample 5 will be enough. Like the sample N equals 5 will be enough. If the parent population is heavily skewed, it needs a larger sample, approximately around 30. If it's tremendously skewed, a much larger sample, billions of observations, will need to be recorded. So
do they figure that the parent population, or let's just start with the A. So what's the shape of the distribution of the sample means for all such samples? They said normally distributed. Is that because it says that the GMAT scores are normally distributed?
Yes.
They basically just give you that one? Okay.
Yeah.
And then how do you know the distribution of the sample means has this shape? And that's we can infer then that because it's normally distributed.
It's normally distributed, yeah.
The population would have to be normally distributed.
Exactly.
Okay.
Yeah.
That makes sense.
Mhm.
Okay. So C, what is the mean of the sampling distribution of sample mean scores for all such samples? And that, they give you that too.
Mhm.
And then the standard deviation of sampling distribution. So
Yeah.
that's the new formula, and it's just
yes. Yeah, it's the deviation divided by the number of sampled. Yeah.
So that's pretty straightforward.
Yeah.
Okay, I think we're good to go then.
Let's try this.
Let's do this. Before I click on anything, I want to make sure that I'm opening the right one because I've opened stuff from the wrong way.
It's gonna be in the group meeting of lesson 6
group meeting.
Mhm. And then it will say start.
I'm the worst with computers.
Yeah. No, it's okay. All right.
Okay. So is everybody in?
Yes, we're in.
Come on, load, open. There we go.
Okay, so it says when taking samples of N equals 5, what is the shape of the distribution of means histogram when the parent population is right skewed? Well, it says it's a sample of 5, so I think that's going to be approximately normal.
But if it's right skewed, won't it be?
It doesn't say how heavily skewed, though.
Well, because
it needs
remember what you were just reading? Oh wait, was it what?
Yeah, I guess if it's heavily skewed, it needs a larger sample around 30.
So I would say then it would still be right skewed because that's a pretty low sample number, only 5.
Okay.
Wait, reread that paragraph though that you read earlier.
Sure. and this is just my notes. I forget where I got it from. It's probably in the textbook. But it says if the parent population is normal, it equals a normal distribution. If the parent population is not normal, it equals approximate normal distribution. If the parent population is almost normal, sample 5 will be enough. Parent population heavily skewed needs some larger sample, around 30. Tremendously skewed, a much larger sample, billions of observations.
It's from the reading, because it just says that it's right skewed, which would not be normal, right?
Yeah.
So it seems like it would still be right skewed if because the sample size is so small. But let me see. Let me open up my text.
The lesson. Yeah, I've got it open. Let's see if I can find it.
Okay.
Okay, I think it's 2.1. Let's see. It's 2.1. When is X normal?
Okay.
It says how many.
X would be.
This is how. Yeah, 2.1 in the textbook.
No, I mean, but what are they referring to with X? Is that the population then?
Yeah.
The population.
Yeah.
Okay.
How many observations are required so that the central limit theorem will assure that the distribution of sample means will be approximately normal? The answer is, it depends. If the parent population is normal, then the sampling distribution of X will always be normally distributed no matter how many observations are selected.
Okay.
If the parent population is not normal, then the sampling distribution X will be approximately normally distributed if the sample size is large enough. If the parent population, and then underneath that, so it says if the parent population is almost normal, mound-shaped and nearly symmetrical, then a sample size of N5 will probably be sufficient to assure that X will be approximately normal distributed. If the parent population is heavily skewed, then it will require a larger sample to be assured that X will be normally distributed. For most moderately skewed distributions, a sample size of around 30 is traditionally thought to be sufficiently large enough. So I think you're right. I think it's right skewed, just from this.
Yeah, because even though the heavy skewed kind of threw me at first, but if it's skewed, it's skewed.
Yeah.
Or else they would call it normal.
Yeah.
Or they'd say it's almost normal.
Wouldn't it have to have a bigger sample size to be
Yes.
considered
Yep.
normal if it's dead right skewed?
Yes.
Okay.
Yeah. So it'll still be skewed unless it's over 30.
Mm-hmm.
Okay.
So
Well, and they say that's
so
a rule.
the next one.
Yeah. Okay, so it gives us a higher one. It says, if the population is right skewed. So this would be normal because it's a big enough number.
Yeah.
It's bigger than 30, right?
Yeah. And that's a rule of thumb. So, but, for this, I think they said several times, let me see if it's in there. They said, I think several times they said for this lesson or something, let's see. For this course, if N is less than 30, we will say the distribution of the sample means will be approximately normal, even if the parent population is not normal. Wait a minute. That's 5 review of concepts. Do you guys see that?
Yeah, but so if you go up back to 2.1, what you were saying, on the very last one says for this course too.
It says up there too.
Sample size is at least 30. We'll conclude that the sampling distribution will be approximately normal.
Okay, so we're good. Okay. All right. So skewed right on number 3, normal on number 4. When taking samples of N equals 5, what was the shape of distributions of means histogram when the parent population is normally distributed?
So that would be normal.
Normal.
Because they were saying it doesn't matter what the size is on a normal, if the parent population is normal.
It's normal, then it would be normal, yeah.
So number 6 is normal as well.
Okay.
Sample size in, what was the shape distribution? Yeah,
Yes.
because it won't matter what the size is
Yes.
of the sample.
When would the distribution of means be normally distributed? This is data, let's see, data or for populations normally distributed in sample sizes large.
It's all of them except for the right skewed with the sample size that's small, right?
Okay, data, let's start, well, I don't know if you guys have all the same, if it's in the same order, but the data are drawn from a population that is normally distributed, and the sample size is small, so that would be correct.
That's correct.
Because any of the normally distributed, it's not going to matter if the sample size is large or small. Data are drawn from a population that is right skewed, and the sample size, so yeah, that's not going to work.
And the data are drawn from a population that is right skewed and the sample is large. So that would be correct. So yeah, it's just the right skewed and small sample size.
That is not, that we don't want to pick, right?
Mm-hmm.
Not highlighted. Yep.
So, okay, so I highlighted the wrong ones. I have that. I have the opposite. Okay.
Yeah. So we want 3, leaving out sample size small for right skewed.
Yes.
Okay, which of the following gives the best explanation of the central limit theorem? Okay, so that's the one with the spread. If the parent population from which the data are drawn is normally distributed, then the sample size X will follow a normal distribution. No, I would say that's not a good definition of central limit theorem. For bell-shaped data, approximately 68% of the data will be within it. Nope, that's not it. If the sample size is large, the sample mean will be closer to the population mean. Yes, that's what it is.
So I have for the central limit theorem, for the correct answer for homework 6, it says the central limit theorem describes what happens to the shape of the distribution of the sample means when the sample size is large. The law of large numbers describes what happens to the spread of the distribution of sample means when the sample size is large.
Yes. Sorry, I had those switched.
Yes, that's what I was thinking.
The central limit will always have to do with the sampling distribution of the
shape of the distribution. Mm-hmm.
Yeah.
So let's see, which one had to do with that?
So on mine, it's the last one, but it's the one that says if the sample size is large, then the shape of the sampling distribution of the sample mean will be approximately normal.
Yeah.
That is the central limit theorem.
Mm-hmm.
Okay. Did everybody get that one?
I think so.
Yes.
I was just reading over the other ones because I hadn't read over them yet. Okay.
Okay, let X be a random variable with a population mean of 10 and population standard deviation of 6. Suppose the sample size 36 is drawn from this population. What is the mean of distribution of sample means?
Oh, the mean is going to be the same as the population mean. So the parent population, so it's, what is that, 10? Yeah.
10.
It says, what is the standard deviation of the distribution of the sample means?
So that's the new
that's where we do the little calculation. So we take 6 and we divide it
by 36.
Well, square rooted, yeah. Oh, hold on. 6 divided by 36. I come up with 1.
Yeah, that's what I came up with.
It says 3 decimal places. Are we doing something wrong?
No.
I think that we just... Go on, sorry.
It's okay.
So...
I thought it was just 6 divided by 36.
Well, it's the square root of 36.
It's the square root of 36. That's the formula.
So 6 divided by 6.
Yeah.
Yeah,
so
it's just 1. So maybe we would do a 3. It must be 1.000 then.
Should we do that?
that would be 3 decimal places, but it's definitely 6. Or, I mean, it's definitely 1, because the square root of 36 is 6.
Mm-hmm.
Divided by 6 is 1.
Right.
Yeah.
I don't want to enter it wrong and then get marked down on it. Just based on how we enter it. So should we do the 0.000 or just do a 1?
I'm going to do 0.00 because
yeah,
3 decimal places.
Okay.
0.00. Oh, I got to do one more. 000. Okay. Regardless of the distribution of the population, if the sample size is large, greater than 30, what would be the shape or distribution of the distribution of the sample? Regardless of well, it would be normal.
Yeah.
Normal, because it's large.
Yes.
What theorem would justify your response to question 11? Well, that would be...
It's talking about the shape, and the shape is, let me go back to my homework assignment. The central Laram theorem describes what happens to the shape of the distribution of sample means. The law of large number describes what happens to the spread of the distribution of sample means when the sample size is large.
Okay.
So
this one's asking the shape of the central limit.
Central limit theorem.
Yep.
Okay. I hope this is right. Let's go back over it really quick before we submit.
So first 2 are fine. Okay. When taking a sample in, what was the shape of the distribution of in? Population is right. That has to be right skewed.
Mm-hmm.
And that one has to be normal because it's a huge number. So these are normal distributions, and those are both normal.
Mm-hmm.
Sample size is. When would the distribution of means be normally distributed? It will be in every example
except for the right skewed small sample size, yeah.
Large. Yep. Okay, which of the following gives the best explanation? And that is this, shape and distribution.
Mm-hmm.
Okay, what is the mean of the distribution of sample means? And they give that to us. It's 10. What is the standard deviation of the distribution of sample means?
1.000.
Yeah, it's got to be that. Regardless of the distribution of population, sample size is greater than 30, then it's normal.
Mm-hmm.
What theorem would justify the response? And it's the central limit theorem.
Mm-hmm.
The large would have to do with the standard deviation, not the shape.
Yeah, and the spread. Mm-hmm. All right.
Okay.
Let's submit it.
Yes, I'm submitting. Yay, we got them right.
Yay!
My heart always...
I know! I always start beating right before I submit. All right. Good job, guys.
Yeah, good job. Okay. So I wanted to ask everybody really quick to get, we don't have to do it, right now. But when do you know, has the Brother Bennett gotten back to you about either adding people to our group, or are we going to, will it just be the 3 of us, do you think?
I think it's just the 3 of us for now, unless he decides to combine some groups or something.
Okay. I was just looking ahead at the our group project.
Mm-hmm.
And now I don't remember if I think there are 6 tasks, so each would just do 2. But there are definitely a couple of them that are more
hefty,
time intensive. Yeah.
Okay.
The other 2. So I don't know if we want to just I don't know if you guys have even had a chance to look at that yet. I was just looking at it because we'll be on a family vacation, so I was trying to mentally prepare for, what I need to be done and everything. But anyway, it's pretty easy. Like the project in and of itself is not going to be difficult.
Okay.
It's just
I haven't looked, so I have no idea. I'm like, group project, yay!
you guys, if you get a chance, maybe just look at that, and then
Okay.
I think our first task or whatever is due on week 6,
Okay.
from what I remember. So that's just a couple weeks away.
Okay.
And I think that one was literally just sort of filling out the worksheet in terms of who's going to do what.
Okay.
But anyway, if you guys, they give us, as for the group project, we have to basically work out a probability, and they give you you have to pick one of the 3 or 4 choices that they give you. So if when you're looking at it, maybe think about which one of those you'd want to do too. And like I said, this isn't for a while. I mean, we have a few weeks, but
it will come up quick.
yeah. And because we have exams next week, we're not going to be doing it next week, but anyway.
I know. As far as our group is concerned, today's the last day to add or drop this class. I'm sure he's waiting until after that.
Oh, that makes sense. Yeah, that makes sense. So he might combine us, but that might change our time too. I don't know if there's anybody else at a similar time. So
yeah, I don't know.
I like this day and time. Works for me, but so.
It's a day off, so I'm good.
All right.
All right. Well, thanks everybody. We'll see you Thursday.
Yep.
All right. Sounds good. Bye, guys.
See you guys.
Oh, Melina, did you record
Thanks for the help.
Did I what?
Are you okay posting again?
Yep.
Oh, thanks for doing that.
Yeah, it takes me 2 seconds, so no big deal. All right. Bye, guys.
Thanks for the help, guys.
Okay, take care.